So let's investigate more details about the sample space and the probability law as the core elements of the probability theory. All right, so sample space. Sample space is nothing but the set of all outcomes that I'm interested in. And there are some conditions that the sample space should satisfy in order to become a meaningful sample space. So for example, if we toss a coin, then the sample space, which is the set of all outcomes, first, it should be mutually exclusive. So by mutually exclusive means that, for example, here, suppose that I'm saying that my sample space like H and T and HT, which does not make sense at all, right? Because the HT, what do we mean by the HT? I mean, it's impossible that we can have both like head or tail, head and tail. They should be head or tail. So it should be mutually exclusive. So the sample space should be like H or T. And the second condition that we need to satisfy is it should be the collectively exhaustive. Collectively exhaustive means that if we include all the outcomes in the sample space, they should cover the entire space. Entire space means that there are no other outcomes which is not included in the sample space. So that's the collectively exhaustive. And also the sample space should be made such that it has the reasonably good the granularity or the right granularity, which means that it does not have to be too concrete or it does not have to be too abstract. So for example, if my interest lies in the figuring out the probability of head or tail of the coin, it's enough that the sample space is H or T. But suppose that my interest is to look at the impact of the weather on the coin's behavior, like rain or no rain. Then just the sample space of the H and T is not enough because my interest lies in looking at the impact of the weather. So we need to study or include all the relevant events of the head or tail of the coin and the rain or no rain of the weather in the sample space. So for example, sample space should be the head and rain, or the tail and rain, or head or no rain, or tail or no rain. So by specifying all these relevant informations in the sample space, now we're good to go and investigate the relation between the weather and the coin's behavior. So my point is that the sample space depends on what my interest is. So let me give you some examples of the sample space. First, if you think about the discrete case, one good example is the two rows of the tetrahedral die. Tetrahedral means that we have four faces in the die. So the sample space would be, because we are throwing, we have two rows of the tetrahedral die, then from the 1 1 and 1 2 and 1 3 up to the 4 4. So we have 16 random outcomes. But if you think about the continuous case of the dropping a needle in a 1x1 plane, then the sample space should be the rectangle of the 1x1 plane, right? And that's obviously the continuous space of the plane. And that's a sample space. Now let's move on to the probability law. So what is the probability law again? We want to assign some numbers to each outcome. But let's think about this thing more carefully. So let me ask the question: what is the probability of dropping a needle at the position like 0.5 and 0.5 over the 1x1 plane? Well, if you think about these things, this probability should be 0, right? Because there are many infinite number of the points in the 1x1 plane. Then the meaning of the assigning numbers to each outcome, because this is one outcome, right? Like dropping a needle at the point at 0.5 and 0.5 is just a one outcome. But in this case, if we assign the numbers to this outcome, this should be 0. So somehow we need to be more careful about defining of what we mean by the assigned numbers. So rather than assigning numbers to each outcome, in order to include a lot of general cases, then we need to assign numbers to each subset of sample space. And a subset of a sample space, which we call event. So the event is a subset of a sample space. And we assign some numbers to each event. So when we use the notation like P of A, and that is the probability of an event A. Since the event is a subset of the sample space, we are dealing with the event using some notion of the sets, right? Because it's a subset. So that's why this is where the probability meets set theory. For example, if we roll a dice of 6 faces, and somebody asks the question, what is the probability of having odd numbers? And having the odd numbers is an event, because that's a subset of a sample space. Here in this case, sample space, as you know, obviously, and the event of an odd number is 135. That's a subset of a sample space. Okay? So the notion of the event is very important thing when we talk about the probability law.